So I'm going to start the first few video tutorials off just showing the end product to see what we're trying to make. And basically what I'm going to make is this right here. It's going to be similar to this. Maybe it's actually probably going to be a lot better. But I have this drone in front of me, and you'll notice the AI. And the particular thing I want you to look at is how the lasers follow the UI. So yeah, that's going to take a little while to understand. You'll notice the lead indicator dot in front of the drone to show where to fire when it's going in a certain direction. It's kind of hard to see. It actually leads towards your lasers hitting the target every time when you point towards the UI. That was very complicated. We're several tutorials from getting there. I don't know exactly how many. This is my first tutorial series, so I don't even want to estimate how many videos it's going to take. But I mean, the lead indicator is going to be a video on of itself. But in today's tutorial, what we're going to be doing is we're going to get a little bit more motion. So I'm going to try to make the tutorials a little bit shorter, like less than 30 minutes. So we're going to do rotation, and I'm going to make a fix for the lasers, because the lasers that I had in the last tutorial weren't really oriented correctly. And there's another thing that we need, because I just had you instantiate the lasers every time they fire, and you don't want to do that in the game. If you instantiate the lasers every single time, what ends up happening is it uses up system resources. So what you want to do is something called pooling, and I'm going to show you how to do that in this tutorial. So we're going to do rotation, which will be simple. We'll get that right out of the way, and then you'll see the problem with the lasers as they are now, and then we're going to fix that, and then we're going to do pooling. So that's what this tutorial is consisting of. All right, we'll get right to it. So in the last tutorial, we did basic motion, forward and back, and we did the firing of the lasers. And you have the scene view and a game view. And the first thing I want to show you is how you can have the game view and the scene view at the same time. So you take the game view tab at the top, and you drag it down to the bottom, and so you have the scene. This one is the asset store in the scene view, but you can just click from the asset store to the scene view, and now you can play the game. And what I want to show you is see that laser prefab? That's the correct orientation. That's the orientation we want. Now look when I fire. It's backwards. If you can see it, the laser is firing backwards. We don't want that, so we're going to have to fix that, and I'm going to show you a fix for that a little later on. The first thing we're going to do is I'm going to get the ship to rotate, so that's going to be easy. What we do, we jump into the Visual Studio, and we click on our ship movement script. So you want to click on this, and I don't know if I want that. So what I'm going to do is go ahead and float. We're going to make a float called X. Gotta stop the attachment. So float X is equal to input dot get axis mouse X. And that's the x-axis of the rotation. Float y is equal to input dot get axis mouse y. And what we're going to want to do is multiply each one by 2, just to make it a little bit more responsive. You might want to even bump it up to like 3 or 4. We're going to multiply it by 2. And this is where it gets a little tricky. You might not understand this, but I do transform dot rotate. So this is going to rotate the body that this is attached to, the ship movement, is attached to the SF fighter model. And you want to do transform.rotate, and you put in parentheses. This is where it doesn't make sense. You think it's X, Y, and Z, and it is, but the rotation of the x-axis, if you think about it, the x-axis is rotating like this, so it changes the y values, right? And the y-axis changes the x-axis values. Actually, for it to be positive, it's going into the negative, right? So it's kind of complicated. You want to do transform.rotate negative y. So for the float y, that's the get axis of the y. And then x, so it's backwards and negative for the y. And you switch the x and y. And there you go. Transform.rotate negative x, y, and z is 0. You don't want to rotate along the z-axis. That wouldn't make sense. You do that in a barrel roll. Okay, so now we should be able to rotate. It was that easy. We're actually going to be doing better kind of forms of rotation later on. But now that you're rotating, look, the lasers look kind of weird, don't they? That doesn't look right. That's not what we want. See, it looks better like when you're going straight, but on the side, they're kind of sideways. You don't want that. So we're going to fix that. But before we do, we're going to do pooling. So we want pooling of system resources. When I'm firing the lasers, and mine's firing 1 per second, I changed the value. You probably have 0.3 of a second. Look, every single time we create clones, and even if you destroy them, it's taxing on system resources. So it stays in the memory even when you destroy it. So what we want to do is something called pooling. And this is going to be like intermediate programming. So we're going to be doing for loops. And so let's get started. On the Leister-Frazier script, we're going to want to make a couple of things. We're going to do, first of all, we're going to do a rate of fire. So we're going to increase the rate of fire. Float rate of fire. And we're going to set that equal to 6.5 F. I'm going to make that a float because the invoke repeating needs a float, not a double. And I'm going to divide this 1. So I put 1 instead of your 0.3. I go down to the invoke repeating on the input.get key down in the void update. And I'm going to do 1 over rate of fire. And so it should fire a lot faster. It's actually 6.5 times faster. And then next we're going to do, let's see, there's the list of game objects, and then what else do I need? I need something else. Let's just start with a list of game objects. I need a pooled amount, so let's do int pooled amount, and we'll do a small number like 10. We're probably going to need a lot more than that, probably more like 20 or 30. But we're going to start with pooled amount 10, so I'll show you how this works. And then I'm going to do a list of game objects. I'll try not to be too confusing with my spelling here, but laser list. I'm going to call that laser list. I don't know if that's such a good idea, but of game objects. I don't know how to do. I'm not very good with lists, so this is List of game objects, laser list. I'm better with arrays, but lists, I don't fully understand how they work totally. I mean, I do. They're not too complicated. I did it on my last project pretty well, but that's the thing. You don't actually have to know how everything works. You just do and mess around, and then like, oh, that works, and then you get a better sense of it the longer you use it. So I'm going to do for int I equal to 0, and then I is less than pooled amount, and then I plus plus. And what we're going to want to do is, I think we're going to want to just take this that we have here and move it here. And then, yeah, that's, so we do the laser beam ints, and I think we want to add, there's something else that I need to do. We'll just type this in. Oh, before we start with the for loop, we want to type in laser list equals new list game object. Yeah. And so user list dot add, and we want to put in laser beam ints, and I'm going to check my cheat sheet because I haven't gotten all this memorized like I did the last one. Oh, of course. I did mess something up. I knew I was missing something. Laser beam ints dot set active equal to false. Okay, that's pretty important. The laser beam ints dot set active equal to false. Yeah, you're gonna need that. Because you're basically like pulling the amount at the beginning, at the start. You're having this laser and you're setting it active to false. And then later you're going to turn it on when we do the shoot laser. And this is where we write the next line of code. So we go to shoot laser, and we're going to want to comment out all of this. I actually might need some of that code to drag and drop, but right now I'm commenting out. That is / asterisk, and then on the last line you do asterisk / and that should comment it out because we don't need it. And we're going to do a for loop, and we're going to do int I equals 0, and then I is less than laser list dot count, and then we do I plus plus, and then we do an if statement. If not laser list, and then we do an I. So it's kind of like an array. If you've ever used an array, we're just saying laser list I dot active in hierarchy. So basically, if it's active in the hierarchy, if not active in the hierarchy, then we basically set it active to true and do all the instantiate stuff. So I'm going to go back to my cheat sheet because this is too much for me to remember. I was working on this earlier. I haven't done it enough times to like memorize it completely. But we have laser list I dot transform dot position is equal to transform dot position. So it's kind of like what we did in the instantiate earlier. I don't even know if this is really necessary, but it's probably an extraneous line of code that's not necessary. But no, it is definitely less necessary. I take that back. It absolutely is necessary. And this is where we fix the lasers. This is so this is an important line of code. Laser list I. So the I laser and the laser list transform dot Euler angles. So we're going to make it so that the Euler angles are right here. We do transform dot rotation dot Euler angles plus new vector 3, and then we make it so that it's correctly oriented 180 degrees on the x-axis. So like I said, it's the x-axis and you're rotating at 180 degrees. You could also probably use the y-axis for this purpose as well. It doesn't matter. And then we want to set it active to true. Laser list I dot set active true. And yeah, that's basically really important to make it an active game object. You don't want to leave that part out. And then we can go ahead and we have this code here, which is pretty much what we want, but it's a little bit different. So I just copied and pasted it. So it's the laser beam inst that you commented out. You can also copy it if you ended up deleting it. You probably didn't want to delete it because it has this code that you have to rewrite. But you just want to take the laser beam inst and just type in laser list I in the code. And there, that should get the correct velocity. So it's like the velocity, and we also want to copy the play one shot sound, which you don't even need laser list I for that. Break. So we're breaking the code every time it invokes repeating. It does this. And so it should look like this, and we're almost done. Actually, we just have one more thing to do, which is quote unquote destroy the lasers. Actually, you want to set them equal to false when you disable them. So we're going to make a new script. We're going to attach it to the laser beam prefab. So we go to the laser beam prefab. And it doesn't have a script. I'm going to move component. So I'm going to add new script. And I'm going to say laser destroy. And we're going to go ahead and open it up. And let's see if I remember how to do this, because I don't have a cheat sheet for this. It should be pretty basic. Void on enable and I think we want an invoke, and we'll invoke inactivate laser, deactivate laser, inactivate, deactivate, activate laser. So it's going to be a deactivate laser method that we're going to make, and we'll set that equal to 3.0f seconds. You can just type in 3, probably work. So then we want to create this deactivate laser. So void deactivate laser method, and we want to do this dot game object dot set active. What is it? Okay. This dot game object dot set active to false. And then one more thing we need to do, I can take out this void update. One thing that's pretty important, we do void on disable, and we do cancel invoke. I don't know why this isn't working. Like, it's not showing me. Not showing me if anything's wrong or anything like that. You know, it's all right. Well, cancel invoke. Huh. I'm pretty sure compiler errors. It didn't show me any compiler errors. Yes, I would like to see what does not exist. So I have capitalization problems, but as it shows up, it's not showing up here. So cancel. I may need to restart Visual Studio because this is not seeming to work too well. Yeah, that's the behavior that I'm looking for. Yeah, it looks like it's all good. So this is pretty much the conclusion of the tutorial. This is what I wanted to do. So I'm gonna show you the code one more time for the so this is what you want. Invoke deactivate lasers 3F, this game object set active to false, and then the cancel of the invoke on the on disable. So yeah, that should pretty much conclude this tutorial. We did everything that I wanted to show you. We've got rotating ship, and we've got lasers pulled. There's one more thing that I wanted to do actually. So this isn't the end of the tutorial. You'll notice that you run out of lasers. So what we do there, I just wanted to show you how the pulling amount is limited and how it like recharges with time. You run out of lasers. You can see in the hierarchy, it runs out, and then you get your lasers back, and then you can fire again. So what we're going to do is increase the pulled amount. I think 30 should be enough. Yeah, I'll just do 32 or something. That should be more than enough. I think 20 is more than enough. But yeah, let's change it to 32. pull them out. So we go into our Leister-Frazier script and we type in 32. And so that should be enough. Yeah, you can fire consistently. And the lasers are oriented correctly. So all this is good. This is a very good progress. If you made it this far, congratulations. We still have a long way to go, but this is lots of progress. So we're moving right along. All right, YouTube, have a good one. Bye.